Okay. All right. Well, good afternoon. I am recovering from the flu, so my voice may not be everything I would like it to be, but we will carry on nonetheless. We're going to talk about biomedical data for about 40-50 minutes. This session was organized by one of my co-authors, Kay Mars, who is the project manager for the NADAP archive. My name is James McNally. I direct the aging program here at ICPSR, and our third co-author, John Marcotte, directs the demography program. Biomedical data and its use within a repository is an evolving topic at ICPSR. This is something we've been working on for well over 5 or 6 years, getting close on to a decade now, and it continues to evolve as the importance of biomedical data evolves. So we'll talk about a broad range of subjects. Certainly we welcome your questions. More importantly, we welcome your input and thoughts, because again, this is an evolving topic for ICPSR. It's something we're committed to, but the tools and the search functions and the way to identify data, anything you have thoughts on, we would be most welcoming to hearing it from you. The presentation itself is part of an emerging debate over how to best define biomedical information found in publicly available data resources. This includes biospecimen information and administrative data, anything that a researcher can obtain access to. The collection of biomedical information is an increasingly important element of research for both the biological and social sciences. Many studies routinely collect information on body mass, diabetes, hypertension, and a wide array of indicators. Information obtained from more intrusive indicators, such as blood draws, medical examinations, etc., they remain less prevalent in secondary data, but their collection is clearly growing. The growing research literature that uses this information drawn from secondary data also reflects the importance of publicly available data containing biomarker information. What remains lacking is a commonly acceptable way to define and identify categories of biomedical descriptive variables, and this is where we're trying to make a contribution. This presentation discussed the state of identifying the presence of biospecimen and biomarker data maintained by ICPSR. It's important to note, however, that while numerous databases, including ICPSR, catalog the existence of biospecimen inventories, as well as data records or publications that report analysis of biospecimen data, these resources are rarely linked to the Biorepository of origin. This is a concern for a number of reasons. Mainly, the biorepositories who provide the specimens that are used in these kinds of analysis do not receive due credit for their contributions to research generation, but also it interferes with our ability to validate or replicate findings, because quite often it's difficult, if not impossible, to know where the specimens came from originally, which biobank provided the information that was used for the analysis. Emerging tools can help organize these independent sources of information into an integrated resource for biorepositories and its users. And this, again, is an area we've been working on for a number of years. Now, the issue of biomarkers at ICPSR. The first thing to understand is that we are an electronic and digital repository. So we do not keep what is known as wet data. We do not keep the specimens themselves. But we are actively interested and actively engaged in collecting information that emerges from the use of wet specimens, from biospecimens, lab results, findings, all the array of things that come from scientists who actually do the analysis on specimen data. So both the collection and use of biomedical information in social research has grown rapidly. This increase reflects both the growing recognition of the importance of understanding the relationships between biomedical measures of health and individual outcomes, and the growth of multidisciplinary research frameworks, which blend social and medical paradigms into knowledge, biosocial research essentially. Unfortunately, the systematic organization of biomarker information into an effective knowledge base has lagged far behind its collections. ICPSR has identified publicly available data with biomarker information data going back as far as the 1700s and earlier. People have been collecting biomedical information for as long as they've been collecting data, and we have rich historical resources that are underutilized. Many people are not even aware that these resources exist. Part of our job is helping researchers identify and find this kind of information. Bridging biomedical and social research has expanded our understanding of issues of health, longevity, and quality of life. Organizing the universe of data underlying this growing body of literature in a manner that facilitates the use of biomedical data as a resource for secondary analysis represents an essential next step. The goals are fairly straightforward here. We want to define the way we see biomeasures, biomarkers, and bioindicators. What are the differences between these measures? And this, to some respect, is an internal ICPSR discussion. I've talked with biomedical researchers who have different perspectives on how these definitions should go, and this is a very healthy dialogue. But at the present time, this is the way we're thinking about data, and we welcome, again, input and thoughts from others. The second goal is to identify data. What kinds of studies are available that contain biomedical information that could be used for secondary analysis? Thirdly, specific measures. What are the different measures? What variables in our collections contain biomedical information and their use in research? What are the potential uses of these biomeasures, markers, and indicators in the research of other people? Okay. Starting with definitions, we have looked at this from this perspective. We see a biomeasure, meaning the direct biological measurement of a physical or mental characteristic without obtaining an actual sample of body material, without a wet specimen, without an actual extraction of material from the person. Height, weight, blood pressure, BMI, cognitive functions such as the mini-mental. These are examples of biomeasures. It's a measurement rather than a specimen. A biomarker, in contrast, defines a direct physical or mental measurement that requires testing procedures or the collection of body matter. Buccal swabs, blood samples, radiology, we would think of these as biomarkers. And then finally, we have a special measure that's unique to secondary data, bioindicators. Bioindicators designate conditions or diseases that are not accompanied by a specific metric. Bioindicators can usually be summarized in one or two indirect measures, which are reported by the respondents when they're questioned. Has a doctor ever told you you have a condition or disease? Or have you ever had a condition or disease are the most common examples of a bioindicator. If we look at biomeasures within the ICPSR collections, we have many examples of this. The National Health Interview Survey, for example, which is an annual repeat measure cross-sectional study done by the National Center for Health Statistics. They routinely collect a number of biomeasures, height, weight, BMI, the number of acute incidents. A more specific example would be the Hispanic EPIs, which looks at epidemiological issues among the Hispanic populations in the United States. Similarly, they collect weight, they collect pulse, they collect height, body mass index, mini-mental exam scores. These are all things that are administered to a respondent, but don't require physical intrusion into their body. So we consider these to be biomeasures. Direct biomarkers in secondary data would include physical or mental measurements which require the examination of the body and body substances. This kind of variable is common in data that reflects medical examination information, such as the CBAS study, which is a study of the elderly in Taiwan. Excellent study. I highly recommend it. It not only collects socioeconomic information, but collects lab measures as well. White blood cell counts, platelet counts, glucose, ApoE, things of that nature. Similarly, the NHANES study, which is done in the United States, they also have a laboratory function. They collect things like blood serum, where they get vitamin D, they'll check your cholesterol, they'll do ultrasounds. All of these variables we have in our collections, and we would consider them to be biomarkers because they involve that next step rather than just asking you or measuring you, actually going in and extracting information from you. And then the self-reported indirect bioindicators that we have in our collections. These indirect measures all present different challenges, both in modeling and interpretation for biosocial research framework. Bioindicators, are simpler. They're easy to collect, but they're also less informative measures. They're based on reporting the presence of conditions or diseases without any evidence of testing confirming the existence of these diseases. Two variations of self-reported bioindicators are both self-reported information. Variation 1 is a reference to specific biomedical tests, but only indicates the taking of the test as opposed to the recorded outcome. For example, has the doctor ever told you that you have a condition or disease? We have an endless variety of these kinds of measures within ICPSR collections. The SABE study of elderly in the Caribbean, for example. Have you ever been told you have diabetes or high blood sugar? Have you ever had cataract surgery? Similarly, the aging status and sense of control study. Ever diagnosed with allergies? Ever diagnosed with breast cancer? Ever diagnosed with heart disease? These questions infer that a doctor has confirmed that these conditions exist, but we have no hard evidence from the doctor's reports. So we're taking this on faith, and that has to be factored into any analysis using these kinds of variables. The other type would be similar to one, but lacks explicit requirement of a physician's diagnosis. These questions collect retrospective information on disease process using questions like, have you ever had? And again, we have numerous examples of these within the ICPSR collections. Longitudinal study of aging, for example, ever had Alzheimer's disease, which I find to be a fascinating question as an aging researcher, but it's a question in the study. Ever had cancer? Ever had an operation for cataracts? Similarly, the Alameda study, arthritis, ever had asthma, ever had cancer? These are just retrospective questions. They provide useful information about biomedical variables, but again, you are taking it on faith that you're getting accurate responses from the respondent. So there is sort of a priority of how you would arrange these in terms of validity, with lab reports being the most precise, and then retrospective questions about your health probably being the least precise. All are useful, but all have to be used in different kind of modeling approaches. I want to talk briefly about HIPAA because this comes up constantly in relation to medical data, and there are some fundamental misunderstandings about HIPAA. HIPAA is important. HIPAA has teeth. HIPAA fines are very serious, and the government is very aggressive about HIPAA regulations and making sure that they're complied with, but they only apply to specific organizations. Okay? Whom does the privacy rule apply? The HIPAA privacy rule applies to health plans, healthcare clearinghouses, and any healthcare provider who electronically transmits health information in connection with certain transactions, which include claims, benefits, eligibility inquiries, referral authorization requests, or other transactions for which DHHS has established standard rules under the HIPAA transactions rules. HIPAA is a law. HIPAA has regulations, it has standards, it has rules. It's important to note that many research organizations that handle individually identifiable health information will not have to comply with a privacy rule because they are not considered covered entities. That's the key word, covered entity. That is what HIPAA is all about. The privacy rule will not directly regulate researchers who are engaged in research within such organizations, even though they may gather, generate, access, and share personal health information. For instance, entities that sponsor health research or create or maintain health information databases may not themselves be covered entities and thus may not be directly subject to the privacy rule. However, as a proviso, always check with your institution, your university, your research organization, your home of work will establish whether you are HIPAA, whether or not you have to follow HIPAA, not you. The key takeaway with HIPAA is it's not about you and your research. It is about where you do your research and whether or not your organization is a covered entity. If you are part of a covered entity, then HIPAA applies to you without any play at all. If you are not part of a covered entity, you do not fall under the HIPAA rule. This will vary greatly from organization to organization, so check with your institution. I can't tell you whether you need to comply with HIPAA or not, but your institution can tell you that. We also recommend that you be familiar with HIPAA regulations, be familiar with the HIPAA privacy rules. There's nothing wrong with them, and certainly complying with HIPAA privacy rules provides greater protection to your data, to your respondents, and to your organization. But just be aware of whether or not you're legally bound to HIPAA, and that's something you'll have to deal with on a case-by-case basis with your institution. I've seen it go in both directions. Now, ICPSR has actively worked to build partnerships with biospecimen and biomedical research communities over the past few years. I'll point out a couple of them. There are many more. For the past decade, we've been working with the study of women's health across the nation, which is one of the premier studies of women's health in the United States. The SWAN maintains both electronic digital data and a biorepository. The aging program, NACDA, within ICPSR currently houses 10 waves of SWAN data, which studies women across time longitudinally. Also, the University of Michigan houses the Biorepository farm where SWAN specimen data is maintained. This has been a very successful partnership, and it's an example of how a digital repository can work with biospecimen data resources, providing services while remaining independent from the specialized talents needed to run a biorepository itself. Another organization is the International Society for Biological and Environmental Repositories. Members of ICPSR have been members of ISBER for, again, almost a decade now, and we actively present and work with them to develop sharing mechanisms where information emerging from biospecimen data can be more easily shared for secondary research. If you're interested in biospecimens and biorepository work, this organization is excellent. They have annual meetings internationally, and they have local meetings in the United States and in various partners in Europe and Asia. So if you're interested in this type of research, you might look into this organization and consider joining. Another organization is BioCaddy. Now, BioCaddy is an initiative to develop a data discovery index, an overarching way of organizing information. One of the members of the BioCaddy team is George Alter, who just recently completed his term as the director of ICPSR and is now a research scientist within ICPSR and ISR. And he's been actively working with this organization for several years to develop tools that will help us better organize biomedical and biological information into a structured vocabulary that will facilitate research. And a number of projects have either spun out of BioCaddy or are related to it. One example would be the National Cancer Institute project GEM, Grid-Enabled Measures Database. This is an open source attempt to allow people to identify constructs, measures, and data sets that impact health information. As you can see on the left-hand side, there's a number of content areas, and then across the top, there's a number of ways the data is organized. If we look at the data sets, it provides a listing of data sets that contain information primarily associated with cancer, but there's other organizations that have a similar schema for specific health outcomes. And as you can see, some of the data comes from ICPSR. This is an excellent idea. It's an emerging idea. It's a growth area. Right now, there's a lot of static information without enough dynamic links to the information contained, but it's the right idea. It's starting to organize broad ideas into themes, into data sets that cover specific areas, into variables that look at specific information and then connect to specific data sets that provide that information. It's an attempt to start drawing in the huge amount of information in the public secondary data universe and organize it in a structured way that allows research. So a big part of what we're doing now is trying to develop partnerships with biorepositories and help them share their information more easily and allow us to better understand their kind of work. We see it very, very simply. We look at the specimen farms where they contain vast amounts of information that has to be analyzed by researchers. They have to take these specimens, tissues, blood, etc., and then in the lab examine them. And then from there, the results of this examination, whether it's on breast cancer, menopause, name a medical subject, then it goes into publications, journals. Then we would like to see this information go into data repositories as secondary data and then result in various additional publications emerging from this original research, because you can never exhaust a data resource with a single publication. Unfortunately, what we see is barriers. The biorepositories themselves, they face limitations. There's only so many tissue samples of specific diseases, particularly rare diseases, so they have to be selective. They have to decide whether or not the investment of an irreplaceable resource will result in a good research outcome. Then the researchers themselves, quite often, the culture of sharing within biomedical research is not as well established as it is within the social sciences. So we're seeing reluctance in sharing information, in sharing the results from an analysis of a specimen, coming into a repository where people can use that information. This is changing, particularly at the federal level, where there's increasing pressure to share information from clinical trials and to provide access to to research information for either validation studies or for new original research. And we see this as a healthy trend. These barriers have existed at various times across a number of disciplines. So we're not concerned. It's just an issue of working with biomedical researchers and helping them to understand the benefits of sharing their information. So part of this is identifying the overlapping relationships. One of the first things I learned when I started working with the biomedical community is their idea of data is very different from a repository's idea of data. We think of data as being the origin information, the zeros and ones and twos and threes that were used to make an analysis. Quite often within the biomedical community, data is seen as the publication. That is the data. If you ask a biomedical researcher if you can use their data, they will hand you the publication. This is linguistics. This is language, and we can overcome that. It's just a process of education. But it was a striking observation that came to me when I first started working with the biomedical researchers. When we work with groups like ISBER, for example, we offer advice. One of the things we argue is that biorepositories, when they release tissue samples or information for analysis, there should be a standardized citation, such as we use at ICPSR, that would identify that the sample came from such and such a repository. This would help repositories track the use of their data, see what outcomes came of it, and also help funding under agencies that support repositories and researchers see a clearer picture of the life cycle of a biospecimen, from extraction from an individual or a donor to publications and research outcomes. This, as any ICPSR user knows, once you have a standardized citation, then it becomes much easier. Excuse me, I have to take a quick water break here. Much better. Once you have a standardized citation, you can find publications much more efficiently and start organizing a universe of research findings around specific information, whether it's a biospecimen, whether it's a study, whether it's a survey. Once you standardize the citation, then it becomes much more simpler to organize information emerging from those resources. And then the literature review is at your fingertips. This is good for you as a researcher because you know what's been done with the data. It's good for a biorepository because they know what was done with their data. It's good for the funders because they can see positive results emerging from this data sharing process. There are very clear incentives for biorepositories to work with digital repositories such as ICPSR. Publications and research justify investment. Outcomes are based upon the use of the specimen for original research and not on the number of specimens distributed. This is very similar to the repository issue, where our funders are not interested in how many data sets we share, but how much research emerges from the data sets that are shared. The investment in time is offset by the competitive advantages of better outcome measures. So investing in creating these standardized bibliographic references that researchers have to use if they obtain a specimen from a specific biorepository offers returns for that time in that they can track outcome measures more effectively. It also allows biorepositories to better identify or prioritize investment in the preservation of specific specimens. What specimens? These all cost money. These all are challenges to maintain. So if you see strong research results coming out of specific specimens, while no research results are coming out of others, it helps you prioritize your resources more effective. And it provides concrete measures of specimen use. There's also incentives for the researcher to comply with this kind of citation or tracking. The information on the use of their deposit in terms of specific research outcomes and better measures of success of deposits for reporting on their own grants and funding. So if you're providing specimens to a biorepository, it provides you with better measures of how those specimens are being used. For the specimen user themselves, compliance is a condition for accessing specimens, but it's also a tool to promote their research findings and results. And citations of their publications are easier arrived at, so other researchers will be more likely to cite the use of their research using specific specimens. These are natural extensions of the kinds of models we've used at ICPSR for years to promote data sharing of electronic resources, and they work just as well within a biospecimen or biomedical context. So this is a little bit confusing, but this is the way we see this flow of information, that there is a constant feedback between the biorepository and the digital archive in terms of information that's available, information that's being released, information that's being used. The researcher has an incentive to inform the biorepository of how their data is used, which in turn helps inform the digital archive of use. And then as secondary publications come out, the researcher finds out that their study is being utilized for new and original research, which again they can inform the biorepository. And it creates a circular flow of information that supports and encourages additional data sharing and benefits both people who are specializing in the maintenance and preservation of biospecimens and digital repositories such as ICPSR, which encourage the use of outcomes from biospecimens in new and original research. So how do you find biomedical data at ICPSR? At present, we're working on that. We have tools. We have excellent tools for finding information, and it's a constant evolution. At present, the best way to find biomeasures within ICPSR is to use our search engine. You can currently search for a wide variety of variables, concepts, constructs, using the search engine. In fact, on the ICPSR YouTube channel, there is an excellent tutorial on using the search functions at ICPSR, and I would recommend that perhaps you might view that at your leisure, because it gives you a lot of tricks and examples of how to use the search functions most effectively. In this example, I searched just simply for diabetes, and what we came up with within ICPSR, we have 1,165 individual studies and 411 studies or series that have variables which address the issue of diabetes. And basically what you'll get is a long list of studies. First, it's collapsed, so series data such as the National Health Interview Survey are grouped into one group, and you can look at that. But what you would do is just sort of look down and see what data is available. However, you can also look specifically at the variables that address diabetes, which we have done here. And what you will get is a list, and there's a lot. See, for example, simply for the term diabetes, we have over 8,000 variables that address diabetes in our repositories. So what you'll get is a list of variables, and it gives you the label, the question text, and the data set it comes from. And this is a way to quickly go through and see what kind of studies have information on diabetes. Carrying it to the next step, you can go through these queries, and if you're looking, for example, if you're looking for the presence of diabetes as opposed to other aspects of diabetes, its impact on activities of daily living, what have you, you can use our compare function. And basically what you do is you would just click variables of interest to you, and in this example I clicked 4, and then you click the compare the variables function. What that will do is pull up a screen that lines up these variables side by side. So you can see each one of these, the variable label is diabetes. The question text, have you ever been told, has a doctor or nurse ever told you, do you have the following health problems? And then it gives you the distributions and also the way it manages missing variables. So it helps you start to think about harmonizing across studies. Gives you the time period, a variety of different information. So this is a very useful tool, and this is the state of the art at the moment. It's very helpful, it's extremely valuable, and we're working on improving it because we're ICPSR. We want to make research easier for you. So we're constantly working on ways to improve our search functions to help you identify new ways of identifying data useful to studies, to papers, to new grants, to whatever you're trying to do. So what we're doing now is thinking about next steps. One of the key challenges facing ICPSR in the coming years is improving our ability to organize and to improve our search capacities for variables. We've got so much data now, and not just at ICPSR, because with organizations like BioCaddy and our own union catalogs and virtual archiving, we're increasingly reaching out into the digital world where data is stored off-site. There's data sets that we don't have. Data sets in Europe, because of legal issues and European data sharing, you can get access to the data, but we cannot physically store it at ICPSR. What we can do is help you find that data and identify the variables. So what we have is a growing, huge ocean of variables and data sets that we need to help you sort through so you can more quickly and efficiently find the data sets and the variables you're interested in, whether it's in biospecimens or any subject. So increasingly, the way we see it, the use of information is less driven by specific data sets. When I was a young man, you could build your entire career just using a single data set like the National Health Interview Survey. That's no longer the case. We're interested in cross-national studies. We're interested in comparative studies. We're interested in harmonized studies. So we're interested not so much in an individual data set, but in specific variable groups: diabetes, hypertension, cancer, specific kinds of cancer, just about anything you can think. But how do we group these into groups, into variable themes? So we suggest that the next stage of development for data searches will involve thematic searches. And this goes back to the work of BioCaddy and the example I showed you by Jem, where they're trying to organize broad concepts first, and then identifying the data sets and the variables that fit into those broad concepts. And we can do that because we already have a step up. We already have the capacity to do searches at the variable level. So for us, it's more an issue of going from the variable up to the themes, where groups like BioCaddy and Jem are starting with themes and then trying to drill down. And this is why collaborative research with organizations like BioCaddy and the work of George Alter has been so useful in our thinking about how to organize this kind of information, particularly in biospecimens and biomedical information, which is just an exploding area of research. So much information is suddenly becoming available with the cancer moonshot, with changes in federal requirements about data sharing for clinical trials. We expect to see a huge increase in biomedical data in the coming years. So how do we think about this? And I think we start thinking about it in terms of thematic searches. What variable groups fit a theme, like cancer, like breast cancer, like hypertension, like diabetes? And then what data sets and variables capture these measures? And that way, the researcher will spend less time going individually through data set by data set and more rapidly identify the groups of studies that address their research needs. And we see this as a potentially valuable contribution to the research community. This approach helps us build upon both the strengths of the existing ICPSR variable search capacities and integrate the innovative work done by BioCaddy and systems such as GEMS. This is an area we're developing. We're not there yet, but it's very clearly an area we want to continue to explore. And input from the user community, from the ICPSR community, from people who use our data would be invaluable in moving this kind of work forward. Particularly expertise in themes. People who have expertise in biomedical research. What variables are important? What variables are less important? How do we prioritize the work we're doing in biomedical research to improve your ability to get your research done? This is the kind of questions we're asking you. And these are the kind of questions I hope you will send us in the coming months and years. In conclusion, the potential for integrated systems clearly exists. Examples such as the work we've done with a SWAN Biorepository at the University of Michigan shows that this process is already being done for individual research projects. New metadata management tools are being developed at ICPSR, and this shows how this process can be extended to multiple collections, housed and maintained at independent sites and also maintained by ICPSR. We can start looking at variable groups side by side. The next step is figuring out what variable groups are important to specific research frameworks. The creation of information resources that reflect not only the presence of biospecimens, but their use and contributions to science offer us all great promise for the future. It requires a multidisciplinary approach, but it will ultimately add considerable marginal value to our collections and to biospecimen repositories as well. So thank you very much for your time, and if there are any questions, I certainly welcome them now, and if any questions come to you in the future, feel free to send me an email at any time. We love to hear from our users, and we love to help you do better research. And thank you very much.